All right, everyone. Assalamu alaikum. Let's begin. Can someone please quickly confirm if you can see my screen?
Yes, sir.
Okay. Just a quick check before we start. How many of you are done with the binomial worksheet already? How many of you have submitted that? I'll actually check that right now because this needs to be done. Let me check and see how many of you have submitted it already. Okay, so 3 of you have submitted it. Ira, Hira, and Hazem, I think. What about the rest
Yes,
of
sir,
you?
that's me.
So what about the rest of you? You have to do it, okay? Mahin, you'll be done by tomorrow night, okay? Abdullah, is Ahmed here? Ahmed is not here. Arham is also not here. Aisha, what about the worksheet? Hira, we've discussed these questions, right? 24 and 23? 24 and 33? Yeah, I think we have in class now. Okay. Okay, Abdullah, please make sure that you do that by tomorrow as well. Aisha, your worksheet is also missing. This is important. This is going to make sure that you retain what you have learned. Otherwise, you will feel that you understand everything, but after a week or so, you'll start forgetting everything. So you have to put into practice what you learn every week. Ideally, every day, whenever we do something, you should, within the next 24 hours, you should try that you attempt the related questions. But if not that, at least during that week, by the end of the week, you should be uh, done with those questions. Okay, that's going to be extremely important. All right, so let's start with our today's session then. We are supposed to continue with quadratics. So we started quadratics in our last session. We were done with some basics. Let me quickly show you what we did. So we started with this, that how we can solve quadratic equations, right? So you've got multiple methods for that. You can use factorization, which we also call midterm breaking. You can do that. That's one possibility. Then we talked about if that doesn't work, you can use the quadratic formula. That's another possibility. We talked about this, that if you have a product, if you have two factors like this, on the other side you have something that's not zero, something other than zero, you cannot do something like this, that you equate each of the factors to that number. This is not correct. You would not do it like this. This only works if you have zero on the right side. Otherwise, it doesn't. So if you had to solve an equation like this, the proper way of doing that would be that you first expand the brackets like this, you multiply them, and then you treat it like a normal quadratic equation. In this case, we could not factorize it. So what we did instead was that we used the quadratic formula. So that's the other method that we had here. Okay, that's what we did in the last session. We learned the two methods that we have for solving quadratic equations. We talked about what it means to solve a quadratic equation, as in what do the answers represent. So for instance, if we have this equation 2x squared plus 7x minus 4 equal to 0, and we get two answers from this, x equals 1 over 2 and x equals minus 4, what do these answers mean? One meaning is that these are the two values of x and the only two values of x that would satisfy this equation. That's one meaning of these values of x being the solutions. And the other meaning is that if we were to draw the graph of this function, y equals 2x squared plus 7x minus 4, the function that you have on the left side here, these values of x represent the x-intercepts of this graph. So they represent -4 and 1/2, the points where the graph intersects the x-axis. Why is that? Because the function is y equals 2x squared plus 7x minus 4. When you replace y with 0, you get this equation, and that's the equation that you were solving there. What happens when we input y equal to 0? We get the x-intercepts, right? So y equal to 0 is the x-axis on this diagram. So if we put y equal to 0, we get the values where the graph intersects the x-axis. That's what we talked about in the last session. Then we talked about the shapes of quadratic graphs. There are two possible shapes like this. You can have a U-shaped graph or an N-shaped graph. How do you figure out which one of the two it's going to be? If the value of a, which is x squared, the coefficient of x squared, if the value of a is positive, you say this is going to be a U-shaped graph. If the value of a is negative, it's going to be an N-shaped graph. Okay, that's how you figure out. It depends on the coefficient of x squared, this value. And then we talked about what these points mean here. The turning points, there are different names that we have for this. You need to know about all of them. These points are called turning points. They're called vertices, vertex. They're also called stationary points. And individually, the left one is called a minimum point and the right one is called a maximum point as well. Okay. The graphs are symmetrical about this turning point, as in if you were to draw a vertical line on these turning points, the graphs would be symmetrical about those vertical lines. So these are the lines of symmetry of these graphs. Okay. And then finally, we said for any quadratic graph, if we look at one side of the turning point, the graph would be decreasing, and on the other side, it would be increasing. Okay. So if the gradient is negative, like in this case, on the left side, the gradient is negative, it's a decreasing part of the graph. On the right side of the turning point, in this case, the graph is increasing because the gradient is positive. And similarly, you can say the same thing for the other graph as well. It's increasing on the left side and decreasing on the right side. Okay, so that's what we talked about. And then we talked about how to find some important points on this graph. So you can find the x-intercepts. X-intercepts, how do you find them? We talked about that already here. When we put y equal to 0 and solve that equation, we get a quadratic equation. You generally get two answers from that. They represent the x-intercepts. You can sometimes have two answers, sometimes have only one answer. So both of the possibilities are there. If similarly, you can find the y-intercept. How do you find the y-intercept? The c, the constant term that you have in the quadratic function, that represents the y-intercept. Okay, because if you input x equal to 0, you're only left with the c at the end. That's the y-intercept. And then the third important thing you have is the turning point. How do you find the turning point? This is one method that we discussed in the last session. We understood where this formula comes from. It comes from the quadratic formula itself. But you have to memorize this. X equals minus b over 2a. What does that give you? That gives you the x coordinate of the turning point. Okay, x equals minus b over 2a. That gives you x coordinate of the turning point of a quadratic function. It's only valid for quadratic functions, not for other types of functions. It's only for quadratic functions. If you have a function that looks like this, ax squared plus bx plus c minus b over 2a will give you the x coordinate of the turning point. How do you find the corresponding y coordinate then? You put this value of x that you get back in the original function, and you get the corresponding value for y from that. Okay, so in this case, we got this turning point minus 3 and 5. So it would be a U-shaped curve like this. And the coordinates of the turning point would be -3 and 5. Why would it be a U-shaped curve? Because the coefficient of x squared is positive. So we have a minimum point here. That's what gives you this turning point -3 and 5. All right, Rizal, you want to say something?
Oh, sir. Excellently.
Okay, all right. So that's what we did in the last session. We talked about how to find the turning point. This was one method of finding the turning point. Okay. Now there's another method for finding the turning point as well, and that is using the completing square method. Let's talk about that method now. This is something that you have done in O-levels, or at least should have done in O-levels. A lot of students, for some reason, tell me that they did not do it in O-levels, thinking that maybe it's not that important. Well, you should not do that with anything, because it's an important concept. You have to know this. Most of you, I think, have done this, but if you haven't, make sure that you understand it now, because you will need to know this for A-levels for sure. It's tested in every other paper. Completing square method. Let's use the same function that we wrote above. Y equals 2x squared plus 12x plus 23. Let me write that here again. Y equals 2x squared plus 12x plus 23. This was the function that we had. We want to complete the square of this function. Now, what's the idea of completing the square? The idea of completing the square is that we have one form of quadratic functions that looks like this. Y equals ax squared plus bx plus c. This is the expanded form, right? This is the expanded form, simplified form. If we wanted to convert it to a perfect square form, a completed square form, it would look like this. This is the standard completed square form that we have for quadratic functions. Y equals a into x minus h whole squared plus k. Why is this called a completed square form? Because this is a completed square, whole squared, right? That's what we're talking about. So we complete a square like this so that we have x minus h whole squared like this. Okay. Now there are multiple methods of completing a square as well. Let's talk about one method that actually uses what we've done here already. So we would not only be using completing square to find the turning point, because when we have to find, when the only goal is to find the turning point, then just using minus b over 2a would work for you. But in questions, they would often ask you to explicitly just complete the square. So they might say, you have this function, you have to write it in this form, maybe 2 into x plus a whole square plus b, something like this, right? This is one form of completed square function, okay? So they might ask you to write this function in this form. Now, how are you going to do that? One possible method is what I'm just going to explain now. So this is the expanded version. This is the standard form of a quadratic function, ax squared plus bx plus c. What you're going to do is, you're going to memorize this other form, the completed square form. Y equals x minus, y equals a into x minus h whole squared plus k. All right. Y equals a into x minus h whole squared plus k. In this form, a is the same as the A that you had in the expanded version. So this A and this A, they are the same. So you already know the value for A. So all we need to do here is we need to input H here and K here and A here. So A is going to be the same as the coefficient of x squared that you had in the original form. Okay, so that's not going to change. Now, the only problem is we need to find H and K. H and K are basically the coordinates of the turning point. Coordinates of the turning point of the quadratic function. Now, don't we already know how to find the coordinates of the turning point using this other method? So this is one quick way of completing the square, that all you do is you just memorize this form, y equals a into x minus h whole square plus k, and you say you have to convert it to that form. You have to convert it to y equals a into x minus h whole square plus k. Now, the only problem is you need to know what the value of a is going to be, what the value of h is going to be, what the value of k is going to be. What about a first of all? A is just the same as this A, which is 2. So we know the value of A is 2. All right. Then H and K are the coordinates of the turning point. What's H? H is the x coordinate. K is the y coordinate. Do we know how to find the x coordinate of the turning point? We learned that here. The x coordinate of the turning point is just given by minus b over 2 times A. That's how you find the x coordinate of the turning point. So can we find that here like that? H equals minus b over 2a. What does that give you? H equals minus 12. Remember, this is what we're talking about. This is a x squared plus bx plus c formed, and that b is 12. What about a? A is 2. So we have minus 12 over 2 times 2. What does that give us? That gives us the value for h, which is negative 3. So h equals negative 3. We have the value of h as well now. What about k? How do you find the value of k? Put this value back in this function to get the corresponding y coordinate. You'll say that's the value of k then. So let's do that. Y equals 2 into minus 3 whole square. We're inputting this value back in this function. Plus 12 into minus 3 plus 23. What do we get from that? Let's quickly do that. 2 into 9 minus 36 plus 23. That's giving me, no, there's something wrong. 2 into 9 minus 36 plus 23. That's 5. So y turns out to be 5 here. This is the value of k. So we have k equal to 5. So we have a equal to 2. We have h equal to negative 3. And we have k equal to 5. These were the 3 things that we needed. Now we can say that function that we had there can be written like this: y equals a into x minus h whole square plus k. Just input values in this. A is 2. X minus 3, that becomes x plus 3. Plus k, k is 5. That's your completed square form. Okay. That's one way to complete the square. All right. So a is the same as before. So this a is coming from here, 2, and then minus 3, this is coming from there, and k is coming from here, it's 5. The turning point was minus 3 and 5 here. These were supposed to be the values for h and k. H is negative 3 and k is 5. So what you do is you find the turning point first using the minus b over 2a method. And then, since you remember this form, y equals a into x minus h whole square, be careful with the signs. You have negative inside the bracket and you have positive outside the bracket. So you have to, this is the standard form, okay? So you have to, if you have to use this method, you would need to remember the signs. So inside, in place of h, you input -3, and in place of k, you input 5, and you get your completed square form. That's your final result. Okay. This is one possible method for completing the square. Now, what if we wanted to use the completing square method to find the turning point in the first place? So we don't want to use this minus b over 2a method. We want to complete the square directly. How do we do that? Now, you could also use another method for that you've actually done in your O-levels. That's the method that most people learn in O-levels. Let's talk about that now. Just so you know, you could do it that way as well, although that is slightly more complicated than this. But if you are comfortable with that, you can do that. 2x squared plus 12x plus 23. This is the function that we have. Another way to complete the square is what you used to do in your O-levels. So remember what you used to do with this. How do you complete the square? What's the first thing that you do? The first thing you do is you take the coefficient of x square common, right? That's the very first thing that you do. Now you can take that common from the first two terms only, or maybe from all the terms. That's your choice. It doesn't matter. Let's say we take them common from all the three terms. That actually requires a bit more working, as in you have to take common from 23 as well. But in my experience, in the past couple of years, I actually taught using just taking common from the first two terms. But a lot of students were making a lot of careless errors in that they were not multiplying things correctly. And it turns out if you take two common from all the terms, it slightly reduces your careless errors. But you can do it both ways. So let's take it common from all the three terms. So what we're going to do now is we take the coefficient of x squared common from all the three terms. Let's try that. What happens when you take two common? We are left with x squared inside plus 6x. And now what you're going to do is you're going to leave some space after this. And then outside, leave some space after this, and then you have 23 divided by 2. All right. So take the coefficient of x squared common from this expression. You get something like this. After the x term, what you do is you leave some space. Now, why are we leaving the space? Because in this space, we are going to do something that is going to complete the square. What exactly do we do here? This is what you have to do. You divide the coefficient of x by 2. That's the first thing you do. What's the coefficient of x? It's 6. You divide that by 2. Then what you do is, whatever is the result that you get from that, you square that result. So divide 6 by 2, square that. Okay. Then what you do is, both add and subtract the result inside the brackets. So when you're taking something common, inside the brackets, you do this. You both add and subtract this number. So how does that work? Let me actually just write it down below here. You can actually do it in one step, but since I'm just explaining right now, these are the steps that we're doing next. I'm just going to copy that here again. What we do is we follow these steps. Divide the coefficient of x by 2. 6 by 2. That gives you 3. Square the result. That gives you 3 squared. Now you're not going to evaluate 3 squared. You're going to leave it as it is. 3 squared. In this form, you say add 3 squared. And also at the same time, subtract 3 squared. Right? The reason for that is you can't just add something out of the blue because it would change the function, right? If you have a y equals, let's say, I don't know, 2x, you can't just say just add 5 to it. It doesn't make any sense. But if you say plus 5 and minus 5 and you want to do use that to do something, that's okay because these will eventually cancel out and you have the same function. So if you have y equals 2x, you could also write it like this, 2x plus 5 minus 5, because it doesn't change anything in the function. However, if we do that here, that we add this thing and also subtract this thing at the same time, this helps us in getting a perfect square out of this. And how will we get a perfect square out of this? Once we have this, these first three terms are going to give us a perfect square. Okay, how is that going to happen? We are going to take x from the first term. So we have three terms here, the first three terms. From the first term, we just take x. Okay. From the second term, we are just going to take the sign, whether it's plus or minus, whatever it is, we just take that sign. And then from this third term, we take the number that is inside the square. Okay, the number that's inside the square. So the first term is going to give us x, what is inside the square, right? The second term is going to give us this sign, whether it's plus or minus, that will be taken from here. And the third term is going to give us this number inside the square. And this whole thing will give us a perfect square inside the brackets, remember. So we have whole brackets like this. Inside, we have x plus 3 whole squared. All right, so we actually color code it like this. This is what we are doing. This x is coming from here, and this plus sign is coming from here, and this 3 is coming from here. And that gives you x plus 3 whole squared like this. Okay, and then the rest of it, you just simplify. So you have minus 3 squared plus 23 over 2. You simplify that. Now, there's another error that a lot of people do here. So you have to be careful. Minus 3 squared. You see, negative sign is outside the square here. So minus 3 squared here does not become plus 9. Okay? Because this negative sign is outside the square. We are only squaring 3. Minus sign is outside, so the negative sign is going to stay there. 3 squared is 9, so you have minus 9 plus 23 over 2. And now we simplify this. We simplify what is inside the bracket first. That gives us x plus 3 whole squared. You keep it as a square now because that's what you want to do in the first place. You want to have a completed square form. Minus 9 plus 23 over 2. What's that? Minus 18. That's 5 over 2. So we have 5 over 2. And then at the end, you multiply this 2 inside the bracket. So 2 gets multiplied with the first bracket, which is going to give you 2 into x plus 3 whole squared. And then 5 over 2 times 2, that is 5. And that's the completed square form that we get from this. And that's exactly what we got previously here as well. Okay, so using this method as well, you can complete the square like this. And now, how do you find the turning point from this? Because here we are assuming that we did not know the turning point already. So we have completed the square first. So if you have this form, how do you find the turning point? How do you find the turning point from this? You compare it with the standard form. Remember, what was the standard form? The standard form looks like this. Y equals a into x minus h whole squared plus k. H and k in this form were the coordinates of the turning point. So you just compare with that and see what do you have in place of h and what do you have in place of k. So let's compare h. So you have to consider the sign along as well. So this is negative h. Negative h corresponds to plus 3. That means minus h is equal to plus 3. That gives us h equal to minus 3. So the value of h is minus 3. Okay. And then what about k? You compare these two. Plus k equals plus 5. So you have plus k equals plus 5. The value of k turns out to be 5. So what's the turning point then? Turning point turns out to be -3 and 5. These are the coordinates of the turning point. A quick way of remembering this is, so by comparison, what's actually happening is you have -h here. So this minus is always going to go to the other side, get multiplied with the number that you have on the right side, and it will change its sign. It will flip its sign. So if you have plus inside, it will become negative, right? So whatever you have inside here in this standard form, in this completed square form, whatever number you have, you basically flip its sign, you change its sign to get the x coordinate of the turning point. Okay. So if it's +3, you make it -3. That gives you the x coordinate. If it was negative, you make it positive to get the x coordinate. But the number outside corresponds to plus k. So in that case, the sign remains the same. So +5, we are not going to change the sign for that. Sorry. So we're not going to change the sign for +5. That's going to just come down as it is. So the y coordinate is +5 in this case. All right. So that's the method that we have for, that's another method that we have for completing the square. Once you have completed the square, you compare it to the standard form and you figure out what the turning point's coordinates are. Okay, I hope that makes sense. Now, you might be wondering why we do these steps. Why do we take the coefficient of x squared common? Why do we divide the coefficient by 2? Why do we square the result? Why do we add and subtract this? Now, there's a whole logic behind it. We can maybe quickly try to understand that if anyone is interested. But before that, let me just write down a few examples here for which you need to figure out what the turning point is going to be. Okay, so it's an exercise because a lot of times what they do is they give you functions in this completed square form already, and then you have to use that form to figure out what the turning point is. So you need to be able to do this as well. So for instance, if you have a function written like this, y equals 4 into x minus 3 whole squared plus 5. You had another function which was -2 into x plus 4 whole squared plus 7. You had another one which was -5 into x plus 5 whole squared, or this is a different number, so there's no confusion. X plus 6 whole squared minus 8, or you could have something like this, y equals 10 into x minus 2 whole squared minus 5. How would you write down the turning points of these functions? That's what you want to quickly understand. So first of all, what's the nature of the turning point? As in, is it maximum or minimum? And then what exactly is the turning point? What are the coordinates of the turning point? So let's write them down. What's the nature of the turning point of the first function? Is it a minimum point or a maximum point? What do you think? Maximum. Is it a minimum point or maximum? Maximum? What's the shape going to look like? Is it a U-shaped graph or an N-shaped graph?
A sad face, the N-shaped graph.
N-shaped graph? Why is that?
Yeah. Because it's 4 and that lies on the positive, like the maximum point will be on the positive side of the y-axis.
Okay, so you're saying the turning point is going to be on the positive side. It's going to be above the x-axis. That's what you're saying, right?
Yes.
It's going to be above the x-axis. But does that necessarily mean that it's going to be a maximum point? Because yes, one possibility is that we get something like this. All right, but why can't we have something like this instead? This is also possible, right? That we have a U-shape above that. It's just that it's not intersecting with the x-axis at all, and that's possible. Could get something like this. No? This is also possible. So you could have a turning point that is above the x-axis that is a minimum point, and also it could be a maximum point. Both possibilities are there. So how do we figure out then if it's maximum or minimum? Yes, the turning point is going to be, let me write down the turning point first, and then we can write down the nature. The turning point in this case, you're right, is going to be 3 and 5. How do we figure that out? We flip the sign of the number inside, we change the sign, that's 3. The number outside keeps the same sign, that's 5. This is the turning point. But what about the nature? How do we know if it's a maximum or a minimum? Abdullah.
Assalamu alaikum, sir.
Alaikum assalam.
Sir, because both the coordinates are positive, we can see the coordinates.
What does that mean? If both the coordinates are positive, what does
The
that
x coordinate is positive 3.
mean? Yeah. So
So it's on the positive axis rather than on negative.
that is okay. So if you had x and y axes like this, you would say yes, that this is 3 and this is 5 and this is the turning point. But how do we know if it's a maximum or a minimum? Because you could have a graph like this, or you could have a graph like this. Aren't both possibilities there? Yeah. Yes, Hazan?
Sir, A, which is 4, is positive, so that's how we know that it's a minimum graph.
It's a minimum point because this is A, right? In expanded form, remember, it's ax squared plus bx plus c. This A outside is the same as this A. It's a positive number. If you were to expand this, the coefficient of x squared would be 4x squared. Coefficient of x squared is positive. That means it's a U-shaped graph. Since it's a U-shaped graph, the turning point is actually going to be a minimum point. So this graph is going to look like this. It's actually a graph that does not intersect the x-axis. It looks like this. Okay. So we will talk about discriminant next. That will maybe make it clearer that there are possibilities like this where the graph does not intersect the x-axis at all. This is possible. Is that all right? Any confusion with this? No?
No.
Let's look at the second one now. Let's look at the second one. What's the turning point? Anyone, quickly. What's the turning point?
-4 plus 7.
-4 plus 7, right? So you flip the sign of the number inside. That's -4. You keep this sign the same. So that's 7. Is it a maximum or a minimum?
Maximum.
It's a maximum because it's an n-shaped graph. It's going to look like this. The coefficient of x squared is negative. It's an n-shaped graph. A is negative, right? So we have a maximum point. Similarly, the next one is also n-shaped because this is negative. So this is also going to be a maximum point. What's the coordinates of the turning point? It's -6 and -8. Change the sign of this, keep this sign the same. And the last one, this number is positive, so it's a U-shaped graph like this. And therefore, the turning point is going to be a minimum. Flip this sign, that gives you 2. That's the x coordinate. Keep the sign outside the same. -5, this is the y coordinate. So these are the coordinates of the turning point and the nature in each case. Is that all right? So if you're given this form, you can figure out what the turning point is and also whether it's a maximum point or it's a minimum point. Okay, I hope that makes sense. So let me just go through this process again. How do you complete the square using this method now? You take the coefficient of x squared common. That's the first thing you do. And then inside the bracket, you look at the coefficient of x, divide that by 2, square that. So if you divide that by 2, in this case, you get 3. Then when you square that, you get 3 squared. You add 3 squared and also subtract 3 squared inside the bracket. The first 3 terms give you a perfect square like this. You take x from the first term, sine from the second term, and this number from the third term. That gives you x plus 3 whole squared. And the remaining numbers, you just simplify like this, minus 9 plus 23 over 2. You multiply the 2 outside, inside the bracket, and that gives you the result. Okay. All right, I hope that makes sense. Now, for any one of you who is curious about it, I'll quickly, in a couple of minutes, explain why we do this here, as in why are we following these steps. You are used to doing these steps and since O-levels, that you take the coefficient of x for common, then you divide by 2, square it, add it, subtract it. But why are we even doing all of this? Let's quickly try to make sense of it. This actually comes from those identities that you've done. Remember those identities like this, a squared plus 2ab plus b squared. What does that give you? That is a plus b whole squared. So basically what we have is a form like this, expanded form. We want to convert it to this form, which is the completed square form. That's the idea. We want to go from the expanded form to the completed square form. So these were, this was one form that we used to have there. The other form was a squared minus 2ab plus b squared. That used to give us a minus b whole squared, right? This process basically comes from there. So for instance, in this case, what we do is to make things easier for us, although you could sometimes do without taking this thing common as well. Sometimes it's possible to complete the square directly, although you would not get the standard form in that case. You would not get this standard form, but you can still complete the square. But it makes it easier if you take the coefficient of x squared common like this. So whenever we take the coefficient of x squared common like this, we are always going to have x squared left inside as the first term. And that's what we have here. We have x squared as the first term, okay? And then we have x term, which is plus 6x. We have these two terms already. What we want to do is, we actually want to convert it to one of these two forms, either the first form or the second form, because if we can convert it to one of those forms, we know we could write it as the form on the right side. That's the idea. So we want to write x squared plus 6x in one of these two forms. What do we do for that? We say, let's compare it with these forms. So the first term that we have is x squared. So if you compare, I'm sorry, what happened here? If you compare the two, where did that go? Yeah. If you compare the two forms, in place of a square, you have x squared, right? So you know, just by looking at it, in this form that you have on top, a should be replaced with what? X. The value of a is x, okay? But then you have a plus sign after that. If you have a plus sign, which of these two forms is it going to be? Because you have a plus sign on the first one, a negative sign on the second one. So we are going to have the first form here instead, rather than the second form. So this sign is going to determine which of these two forms it is. And that's why we have plus in one of these, minus in the other, because this sign here determines whether we're going to have a plus sign on the right or a negative sign on the right. Now, since in our example, we have a plus, which one are we looking at? We're looking at the first case. Okay. Now, if you're looking at the first case, we know that the second term is 6x. The idea is to find out what B is. Because once we know we have A as X, we can figure out, okay, in this form, A plus B whole squared, A is going to be X. Then we're going to have a plus sign because of this plus sign. The only problem is, what are we going to have in place of B? Right? That's the only problem. What are we going to replace B with? How do you figure that out? We just compare these two. We say, okay, this is 2 into AB. This is 6X. Let's compare the two. 2AB should correspond to 6X. Now we know A is just X, right? So we can just replace A with X. We get 2XB. That should be equal to 6X. How do you find B from this? You find B like this, 6X over 2X. So X and X get cancelled. B is basically 6 over 2. Okay, B is 6 over 2. That's why we divide by 2 there. In this case, we divide 6 by 2 to get the value of B. That's why we divide by 2 like this here. And once we know that B is supposed to be 6 over 2, what do we need with this? We want a B square. So for that reason, we square this thing. 6 over 2 is 3. We square 3 like this and add it to that expression. But since we can't just add something like this, right? It will just change the expression. You have this number. You can't just add 9 there out of the blue. So you balance that. You say, okay, I'm adding 9 here, but I'm also balancing that here. I'm subtracting 9 as well so that the overall result stays the same. But how it benefits us is that these first 3 terms now give us that perfect square. And from this we get X plus 3 whole squared. That's A plus B whole squared like this. Okay, so that's where this comes from. So even if you don't understand all of that, at least I hope it gave you some intuition of why we're doing this. But that's how the process works. This is how you complete the square for a quadratic function. So what have we done now? We started from this. In order to find turning point, if you are only looking for a turning point, all you need to do is you need to use this formula. X equals minus b over 2a. That is going to give you the x coordinate of the turning point. And then you can find the corresponding y coordinate by inputting this value of x back in the function. Okay, if you're just looking for the turning point, this is sufficient. But sometimes they specifically ask you to complete the square. In that case, there are 2 methods that we have learned. One possibility is that you find the turning point first using that minus b over 2a method. Find the turning point. Turning point is going to be h and k, and then just input those values in this form. A into x minus h whole square plus k. Just input those values here, and you would get the form. Okay, that's one possibility. The other possibility is using this other method where we just follow this whole process to complete the square. You can use whichever of these you prefer. You can try doing a few questions using both methods and then see which one you are more comfortable with, which one you are making less errors in. Different people prefer different methods. You can see what works better for you. Okay. One last point before we end. Sometimes they give you a slightly non-standard completed square form. So for instance, you might have something like this. You might have a quadratic function that looks like this. Y equals 4x squared plus 16x minus 15. You could have a function like this. Or let me actually make it, let's say 4x squared plus 20x minus 15. This is a function that we have. They might ask you to convert it to this form. Y equals 2x plus a whole squared plus b. You might write something like this. That converted to this form. Now remember, what was the standard completed square form? The standard form that we learned above was this: y equals a into x minus, I'm sorry about that, y equals a into x minus h whole squared plus k. That's the standard form that we learned. This is not the standard form. So they might ask you to write this function. So they might say, write this expression in the form that's given here. Now, how is it different from the standard completed square form? What's the difference? In the standard form, you only have an x here inside the bracket. You can't have something other than x here. Here you have 2x plus a. So that's slightly different. Okay, it's not the standard form. Now, how are you going to do? How are you going to complete the square in a case like this? How are you going to get this form exactly? One possibility is that you use the same method as before. The same method as before. What did we use before? Used to do before? We used to convert to the standard form. So you just convert to the standard form, just like we used to do before. Convert it to standard form first of all. Now you can use any of the two methods for this. You can either take 4 common, then divide 5 by 2, square that, add the number, subtract the number, and then simplify everything. I think the other method is much quicker and easier, less prone to error. So I'm going to use that. We know a equals 4 in this form, right? What about h? H equals minus b over 2a. What's b? This is the standard form, right? ax squared plus bx plus c. In place of b, we input 20. So that's minus 20 divided by 2 into 4. What do we get from this? It's minus 5 over 2. That's the value of h that we get, minus 5 over 2. And then we find k as well. Put this back in this function. 4 into minus 5 over 2 whole squared plus 20 into minus 5 over 2 minus 15. Just evaluate this. That will be the value for k. And you will have your completed square form. So let's do that. 4 into 25 divided by 4 minus 100 divided by 2 minus 15. So I'm getting minus 40 from this. Can somebody confirm this as well? Minus 40, is that what we get? Right? So k equals minus 40. Now we can write it down in the standard form. What's the standard form? Y equals a, which is 4, into x minus 5 over 2. That becomes x plus 5 over 2. And then outside you have minus 40. That's the standard form that we get. Okay. But the question said you have to convert to this form. What's the difference? Inside, you have x in your form. They have 2x. You have 4 outside the form. They don't have anything outside the form. So basically, the idea is the number that you've got outside, you just want to bring that inside the bracket. Now, how do you do that? You can't just multiply 4 inside because 4 has power 1. This has power 2. You can't multiply two things that have different powers, right? Basic indices rules. But what you can do is, if they had the same power, we could multiply the two numbers. So the trick here is, the number outside, we write that as 2 squared. Right? 4 is the same as 2 squared. So we can write it like this. And that leaves us with x plus 5 over 2 whole squared inside, and you have minus 40 like this. Now these numbers have the same powers. So we can multiply these numbers. We can multiply 2 and this bracket and have a whole square on top of that. So now 2 into x. So we could do it like this. Let me just add one more step. You don't necessarily need to write this, but just to make sure that you understand. Since they have the same powers, we can just multiply the bases, right? And that gives us 2x plus 5 whole squared minus 40. And that is the form that they were looking for here. So you just convert the function to the standard form. And then whatever is the number outside, you write that as a square and then multiply that inside. And that will give you the form that was required there. Okay, so this is the proper way of doing this. Some people are actually able to do this quicker, but that does not work for everyone. I'll just tell you another way to do this. But if this works for you, this is what most of you will be required to do. Okay, this is what most of you will be required to do, that you would convert it to, you'll write down the standard form first and then multiply the number outside inside. Now, some people who can do some calculations in their head directly, just another method for them, which is quicker, just in case you're one of them, you can use them. Use this method as well. 44x squared plus 20x minus 15. What did we want to do? We wanted to convert it to this form, y equals 2x plus a whole squared plus b. That's the form that we wanted. The other possibility could be that you just think of, where was that? Yeah, you just think of these identities directly. So if you are smart like that, as in if you can think like that, you can do it directly, like convert it directly to that form. Now, how do you do that? You have a plus sign here, right? So you know which form are we talking about? We're talking about this form, a squared plus 2ab. So let me write it down here. A squared plus 2ab plus b squared. This will need to be converted to a plus b whole squared. That's the form that we're talking about. How do we convert to that? 4x squared. Can we write it as a perfect square? We could write 4x squared like this, 2x whole squared. So now we know that a is the same thing as 2x, right? And then you know that this a is supposed to be 2x, so that's 2x as well. And this b is something that you do not know. But what do you want at the end? You want 20x at the end? You have 2 into 2x. What would you need to input here to make it 20x? You have 4x already. What do you need here?
10.
Think again. You have 2 into 2x. You have 4x.
5.
You want to make, so you have 5 here, right? So you need to input 5 here. So that means b should be 5. So the form that we're going to get then is going to be 2x plus 5 like this. So how do you complete the square now? For completing the square, you would now need to add b square, right? Because we have the first two terms for now, a square and 2ab. You add b square, which is going to be 5 squared. You add that here. And then to balance that, you subtract that. And then you have this remaining number, which is minus 15. These terms are going to give you a perfect square, which looks like this, y equals 2x plus 5 whole squared. You simplify the number outside. That's minus 25 minus 15. This is a quicker way of doing this, but it's harder. If you think it's going to work for you, you could use this as well. Otherwise, most people, 90% of the students, they use the previous method that we learned. कि standard form में बस convert कर दें, because उसका process तो आपको आता है, वो तो आना चाहिए आपको, वो तो process आपको आता है कि standard form में क्या करना है. जब standard form में convert कर लेंगे, okay, I'm sorry, I again switched to Urdu. I'm sorry, Hazem. So basically, you already know the process for the previous method, right? How to convert to the standard form. You already know this, right? All you need to do after that is you just need to multiply the number outside inside by writing it as a square first of all. So this method will work for everyone, right? So 90% students do it like this. But if you understand this method as well and you think you can do it, you can perhaps use this method as well. That's an alternative that you have. All right, so that's all about completing square. A lot of people find this a bit complicated. I hope this was helpful, but it's only going to work for you if you do some practice questions now. Okay, so make sure that you do 4 or 5 questions on this. At a minimum, you have some on this in the worksheet where they ask you to convert a function to a form like this. So make sure that you attempt those questions. In the next class, we'll be talking about discriminant, which is b square minus 4ac, and its applications. Anyone who has any questions on what you've learned today, let me know.
No.
No
Sir,
problems?
can you explain
Yes.
the other method again?
This
The one
one
where
that we
we
have
got
just finished?
2x plus a. No, not this one, the one before it.
Okay. So do you understand the part until this point? Because this is the standard complete square method, right? Up to this point.
Yes, I understand this part.
Okay. After this point, what we're doing is, think of this. Let's say you have x squared into y squared. If you have two expressions multiplying and they have the same power, x squared and y squared, you could write it as xy whole squared, right? But if they were different powers, you could not do that. In this case, we have 4 raised to power 1. There's no power in 4. That means it's 4 raised to power 1, right? And this is power 2. We can't multiply these two as of now. At this step, we can't do anything because they have different powers. We can't multiply numbers that have different powers. So what we do is, we say, let's write this 4 as a square as well. So instead of writing 4, we say, let's write it as 2 squared. Okay. Now, once we do that, both of these expressions have the same power. And when they have the same power, we can write them together like this and make this whole power. Right? So we can just multiply 2 with this expression. That becomes 2x plus 5. And you have whole power 2 like this. And that's the form that we wanted. We wanted 2 inside the bracket like this. So we're just using those indices rules, making the power the same and then multiplying the bases.
Okay, thank you, sir.
Okay. Any other problems, anyone? Any questions? All right, that's it then. I'll see you again on Thursday. You can start doing some questions from the worksheet. You will not be able to do all of them, just a few, but at least some parts of every question. So you have time until Thursday. You can try some of them. After Thursday, you will be able to do a number of them, but you can start right now maybe. Try some parts and you might actually remember some concepts from what you've studied before. So you could try the other questions at least. And then when we discuss those concepts in class on Thursday, it'll become a bit more clear, inshallah. Okay. All right. So that's it. I think you don't have any problems, any questions. I'll see you again Thursday then. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.